welcome back, guys. Welcome back. I'm so happy to have you all again on this in the channel. Okay, in the previous video we actually talked about the getline function. Now in this video we'll be talking about string word splitting, and then I'll be doing a quick introduction so we could actually wrap things up quickly. I'll be doing quick introduction to system calls and what are now library calls. So now I'm going to come to my shell here. Okay, so let me do a clear here. Sorry. Alright, so now perfect. Now when we talk about string splitting, remember our aim here is to build a shell just like this, our bash shell. Now when we type in let me just quickly use that, then let me type in this sudo, then ls, then this, to actually list out all the files in my root folder. Now what the shell is actually saying is what? 3 arguments actually: the sudo, which is 1, the ls, which is 2, and this, which is 3, not a string that contains sudo space ls space / It's actually saying what 3 argument that is being passed to my bash shell, which is the sudo, which is the name of the program, ls, which becomes an argument to my sudo, and the /, which becomes the argument. Alright, so now in the same vein that the shell is able to split this string, or is able to break down this string into what arguments, is the same way we are being tasked to actually take our string and break it down. Now when it's being broken down, you could call it seeds, or you could call it what? Tokens. So that is the whole concept here, because it is one of the it is basically the way in which the shell is used in interpreting our programs. So I'm just going to continue. Okay, now for me to do this this operation, I have to use my strtok function. So let's just quickly open the mount page for strtok function so I could just explain a few things there. Now in the strtok function, for me to use it, I'll first of all need to include what? The string.h library. Now the prototype of the strtok function is that it's going to take what is going to read from, which is a pointer, or which is a string, but you could put it this way: it's going to read from, and what is going to act as what? The delimiter. Now by delimiter I mean what is going, the character or the string or whatever that the string token function is going to use as an indicator to break it. Now I'm coming back here now. Now look at this. Now my bash shell is able to break this into three individual arguments, or you could say into 3 individual commands, because of what? There's a white space here. So my white space now is serving as the delimiter here, in this case to my what? Bash shell. So in the same way here, you could decide to use your white space here as your delimiter. You could decide to use a semicolon, a /, or a particular character, or even a particular string as your delimiter. Now what string token function is going to do, it's going to read till it hits that delimiter, and then it's going to break. Now let's say white space is our delimiter here, and let's assume the user passes what? From feature down to requirements. Now if I'm going to be using white space as my delimiter, is the straight token function is going to start reading from here, and then it's going to end here, because it has encountered a white space here. So it's going to read from here to here and then return the string, which brings me to the return part. It's going to return a pointer to the string that has read. Now when it does this, it's actually called token. This part that is actually read is now called token. Now string token function is actually a destructive function. I'll get to the part where it's actually a destructive kind of way we do this, but let's take things slow and steady first. Okay, so my string token function is going to take what I'm going to read from and the separator or the delimiter, and then it's going to break it and then return and just going to return a pointer to that string there. Is going to return a pointer to that string. Now this is the first call to the string token function, the first call. Now if I'm going to read read all this, remember we said from here to here, and then break it down into token, it means that I'm going to be calling my string token function, like let's count: the first call, the second, the third, and the fourth. It means I'm going to be calling my string token function 4 times for me to be able to actually read this full line from here, assuming this is what it is assuming this is what this variable str is containing, to actually get down the tokens, right? So means I could put the string token function in a loop to actually read a string. Now how do we know if string token function is done reading? Well, we could know with the return value. Now string token function is going to return null or the string. Now it's going to return null if there is no longer a string to be tokenized again, and is going to return the string in which it has tokenized from the main string, meaning it's going to return a substring from a main string when it can find it. If it cannot find a substring in the main string, is then going to return null. Like going back to my example here, you can see here I have feature, test, macro, and requirements. Now feature itself, it's a string in this entire string, so feature here becomes my sub string. So that's what I'm just trying to actually convey to us, that the string token function is actually going to return a substring from a main string if it can get according to the delimiter set, because it's basically going to do this according to your delimiter set. Your delimiter can also be test. Let's assume my delimiter here is test and not white space. So what my string token function is then going to do is going to for me to actually get this string now into tokens, I just need to call my string token function twice, because the first call is going to read from this white space, from this feature here down to this white space here, and then this test becomes the point where it's going to break, and then the second time I'm going to call it is going to read from this second white space down to requirement, because we have said test is our separator, or is our delimiter, or is our indicator to the end of the substring there. Okay, now we've understood the part of or how the string token function is. Let's get down to actually using this function. All right guys, if you are just joining us, please I would advise us to watch the previous video where we actually discussed about processes, arguments to main, void arguments, and the getline function. I'll also appreciate if you could give this video a like, and also share it out to all ALX students who will be undertaking this simple shell project. All right, and if you also have more questions, or probably there are some other things you might find difficult to understand, or probably you have more suggestions or a question, you could just drop it in the comment section, and then let's just get to learn together. All right, so I'm just going to continue from so this was where we stopped. This was when we stopped in the last video, when we were writing using our getline function. So now I'm just going to continue from this point, because our aim is to actually build a shell. So I'm just going to start from here we stop, kind of writing a super simple basic shell here. Okay, so my getline function has succeeded in reading this the line, and here it's going to print out whatever that has been read, and here I'm just reading out the number of characters that it read. Okay, all right, now after I have read this, now I want to then split this. Okay, so if I split this, and I know that my string token function is going to do this very perfect for me. So well, I just need to call my string token function, right? So yeah, let's go. So just take this down a bit, so I could just call my string token function, and then I need to pass in where it's going to read from, which is both. Now my delimiter. Now you could decide to create a variable and call it delimiter or separator, and give it your preferred value to be your separator, and then you come here and you pass in delimiter, and it's still going to work. But for me, I find it not really cool, because it's just to tokenize a string that I'm basically calling my string token function, and after tokenizing, I don't really need the delimiter variable again. So there's no point in me actually creating a variable just for my delimiter. So I'm just going to pass in my delimiter directly to the string token function, and my delimiter here is going to be my white space. So I'm just going to come here and do this. But is this complete? Well, no. We've only succeeded in filling the argument part of the string token function. But now what about the return? Because we have said that the string token function is going to return is going to return two things. Now the first one is going to return in two cases, rather, not two things, two cases. Now in the first case is when it can find the substring inside your main string, is just going to return my substring. Now since my string token function is going to return my substring, I will need to save it in a variable to hold it, because it's a valuable data for me. I'm breaking it down, so it's very valuable for me. So I will need a variable to actually save this. Now the second question here is, now what type of variable? Sure, am I going to save it as a string? Well, since I'm collecting it, or I'm breaking it from a string, it's to me makes no sense in actually still saving it to a string, because the string token function is reading from this buff, and this buff is a string variable. So there's no point in me actually putting it in another string variable again, or except I decide to then create a multiple variables, multiple sub variable, like say I can say token 1, token 2, token 3, and then start calling my string token function to return the substring and then initialize token 1, token 2 with their appropriate respective values. Or a better way is I could use the concept of what array of what strings, and that is what I'm actually going to use. I'm just going to use my array of strings. So from first things first, I'm going to come in here and then I have to declare that. I have to declare my array of strings. Let's say my array of strings should just be called tokens because there'll be more than one. Then let me just first initialize it with null. Now I'm going to come in here. Now because at some point the entered string from the user might be very, very large. So, and I don't want a situation whereby I am actually using too much space or little space. I just want everything to be perfect at what runtime. Now, in creating a space for my token, I can make a call to malloc. So I could say tokens malloc, and then I need to ask malloc. I need to tell malloc the amount or the size in bytes, right? Okay, now I can actually do the string length of what buff and then close the statement. Now because I'm using the strlen function, now I have to come in here and include it. So I'm just going to include that. Okay, all right, so now I have made a call to malloc to return the length of this should return the length in bytes. Okay, now why am I doing this? Like Sammy, why are you actually doing this? Well, now let's look. Buff actually holds the user inputs, right? It's being saved as a string. Now even if I'm going, but now look at this, I'm saving this as an array of strings, right? Now but the value, it's still the same. That's where I want to take our mind to. That is, if the user actually entered malloc field as the inputs, if I'm going to save this in memory of this, it's still going to be the same length, but the difference here is at index 0 is going to occupy this, index 1 is going to then occupy this. But if I add this and this together, I'm actually still going to get the total length. So that is the reason why I want to save this into malloc. I want to save this into this tokens. Now malloc is going to return that address, right? So I'll quickly pass in a check to see if malloc failed. So I can say if tokens is null, then I want to print error field error, comma, failed to allocate memory. Okay, then put in my \n, then put in my return, because there will be no point proceeding further since equal to malloc was failed. Now, okay, now with that check, now if it passes this if check here, that means it actually return with an address. Now that address that it's going to return, I now want to use that address, so I'm just going to say tokens at index idx. Now I have not actually declared a variable called idx, of which I'm very aware of, so I'm just come in here, then make int idx. I'm just giving initial value of 0. Okay, so everything is looking much more beautiful and easy to read. Okay, now I'm then going to call my string token function, then I'm going to pass buff, then my delimiter here. Now this is the first call to my string token function, so I'm just going to remove this here. Now this is the first call to my string token function, and it's going to return the first substring that it's found. Now I am not done, because I want to continue reading and tokenizing the user input. Now I don't know the amount of string or the amount of data the user is actually going to send, so I will have to put string token function in a loop so that it could actually tokenize all the strings for me, right? Okay, so but now since we know we are going to use a loop, what would then be our loop condition? Well, we need not to think too much about it. We need to remember that we need to remember the return value of the string token function. Remember, it is going to return depending on the case. Now the first case is if it is able to actually get the substring from the main string, then it's going to return that substring. If it can't, it's then going to return null. So then my condition will then be, I'm just going to use a while loop here. This when token at idx is not equal to null, then I'm just going to do tokens. So first thing first, I will have to increase my idx, because idx is at 0 and at index 0 is containing the string returned from my first call to string token function. So I'm going to terminate this here, so to increase idx by 1. Okay, then I'll encode an idx equal to my second call now to string token function. Now I am passing null here because now it's basically because I am still using the same string here, which is buff. Now if I was using a different string, now I could then put in another, I could then leave here as probably put there here to be the variable name containing that string. But because my first call, please take note, my first call to string token function, I said I wanted to read from buff. So when it was done reading that first substring, is actually going to the string token function is smart enough to save a pointer to the next place, so that if you are calling it for the second time or for n amount of time, it's going to know where it's going to start from. Okay, so that's basically. So since I'm using buff here, there's no point in me. If I could still come in and still pull buff, well, it's still going to give me the same, but there's no point. So that's why I just passed in what no. So because here is no, it's going to go back to the first call to string token function and then check where the pointer is pointing to, and then starts comparing to get the substring from it. Okay, so that's basically our algorithm inside here. So I'm saying while tokens at idx is not equal to null, I'm increasing idx first, then token at that index should be hold the return value of the string token function. Now we should also remember that our array of strings are always not terminated. Now we don't really need to bother about that because we already know that string token function is going to return what? Null. Okay, so basically this is all we need to actually get that and save it into my tokens. Now what if I want to then see it? So I have to first come in here and return idx to 0. I want to print. Okay, because I want to print this, I will have to still put tokens in a loop and then print it out. Okay, so I'm just going to say while our tokens, sorry, I have to put this inside my parentheses, at idx is not equal to null. Okay, then I want to come in here, sorry, that ought to be a p. Yep, then I want to say token so I could actually see them properly. It's going to be an integer, sorry, snd not s. Then you show the string. I want to print them on separate lines, so I'm putting my backslash n, then first in my idx, then my token. Okay, so this is basically it. I am printing, and then I'll need to increase my idx. So here now I'm using post incremental operator, so I'm printing this and then I'm increasing. So when this idea increase to a value that at that value it will do not byte it, then this while loop condition here becomes false. Hence the statements inside here are no longer evaluated. So now let's see if what we did is correct by compiling code to DCC. We'll call it talk. Okay, just going to run talk. Say this is sammykingx. Now you can see, say this is and sammykingx. Now it's not printing at index 0. It started printing at index 1. Well, this is because here we are actually what increasing idx first. So idx at this point, idx before idx was 0, but at this point idx became what 1, and then I'm increased. Okay, no, for my printing, yes. Okay, so wait, let's take a closer look here, and let's see why idx tokens at index 0 never printed. Let's see. So this, okay, oh, it actually printed, sorry. So I think it actually printed. So my first call to print, my most recent call to print that gave me this new bytes. Yeah, I didn't put the \n there. So here I didn't put the \n here. Yes, I didn't put the \n there. Let me just remove. Okay, so now everything should be in order now. This is sammykingx. Now you can see tokens 0, which is this tokens is at index 1, tokens are index 2 is what sammykingx. So we are able to now read this and then save them into tokens. Now this extra white space you are seeing here is because of this butcher here. Okay, I thought I actually added the butcher. Okay, so let's figure out where the extra white space is coming from. Oh, okay, now I know where the extra white space is coming from. Sorry, the extra I know where the extra what are they calling it, the extra new line character is coming from. The extra new line character is actually coming from my getline function. Remember that getline function is actually going to add in a \n. So at this sammykingx here, there's a \n also there. That's my shell saw. Now in here also I am actually printing a \n again. So what I'm saying in essence is that what is actually in tokens and index 2 is actually sammykingx \n. That's what is there. Now for my printf statement, so I'll then did this. So that's why you're seeing this gap there. Okay, all right. Wow, the video is already very long. Oopsie. Okay, so in the next video I'll be explaining about system calls and library calls, and then we'll start talking very well on fork, orphan, the zombie, and then we're beginning to get our data, and then we could see that we're actually getting to see our simple shell using the C program come alive gradually. All right, thank you for watching till this point. If you have any question, please drop it in the comment section, and do try to share so that we could help everybody that's actually taking this project. All right guys, have a wonderful day.